Now today we are going to see about USB verification environment where we have implemented the host controller state. So in host we are having first we will see the host transaction top. So this module host controller top module include host transaction FSM and counter FSM. So two FSMs are there. One is transaction FSM and one is counter module. Now you see host transaction top, in which you can see that UTMI related signals are there, and all are UTMI related signals. And here we are including the parameter file. So before that we declared the port list and we defined all the ports. Now after that we are including some constants which are defined in parameter file. So name of that file is USB host bfm parameter.h. So next we are defining the port declaration. So input,
Excuse me. Here you added a .h parameter file. We can use a .v extension also, right?
right?
Will it create any difference while compilation emulation?
No, it will not create any difference.
Okay.
Okay.
So
Wait.
both are same.
Both are same.
Okay.
No problem. Now after that you see some ports are there. Input ports, output ports. This is port declarations. Now after that we are data type declaration. You can see here where we are defining. Since this is the host BFM top, so what all child modules that this top will include is, first is the host transaction FSM BFM. Okay, so host transaction FSM BFM, we are calling that module, and the module name is host transaction FSM underscore BFM, and after that we are instantiating that module with name. So here we are following instantiation with name. So top underscore host underscore trans underscore FSM underscore BFM underscore top underscore clock underscore I is the port name from the child module, and we are using one wire, that is top underscore host underscore reset underscore top underscore clock underscore I. So we are connecting this port with this wire. Similarly we are doing the same thing for all the ports. Okay, in this we are going to data state. At passage of clock we are sending data, send data. So in this way we are sending PID address, endpoint number, and CRC5 to the USB. Now coming to, now if you are sending a in token, now we know that in host may send any type of token. In token, in we know that a host can send a token packet. So when host is sending a token packet, so in that case whether it may be in token or out token. So for out token we have seen that how to enable the transaction. Now coming to in token, so when in token is there, now you have to send first PID. So this is the PID pertaining to in token, and next cycle we are sending address, and at next cycle we are sending address endpoint plus CRC5. Okay, and we are going to receive state, because when we are sending PID in token, this means that host is going to receive the data and next cycle. So that's why we are going to receive state, where we are going to receive the data from the device. Now if third situation is if your PID is start of flag token, start of frame token, so during that time you are preparing this data out, and else if it is a setup token, so we are sending this data. So right now we only implemented in token and out token. So information pertaining to in token and out token is available in this code. Now coming to send data stage will only come when host is when PID out token is going towards the USB. So in that case you can see that if ready is high and transaction is not over, during that time we are sending TX valid and data towards the USB. Okay, So like this we are sending the data. Okay, so we can send any amount of data, but here what we are doing, we are sending this data. PID is we are sending first, then we are sending data, then we are sending CRC low 8 bits and CRC above 8 bits. Why we are sending CRC in two clocks means CRC is 16 bit, where our interface UTMI interface is 8 bit interface, so we can't send whole 16 bits together. So at 8 bits we are sending in each and every cycle. Okay.